Good morning. I've had several people that have gotten started on your homework this week and in your problems, and I've had a few people that have asked me for some help with section 1.1, the homework, and question number 5. I like to refer to this question as the crazy map question. It does require a lot of high-level thinking for this, but it's also a really neat way that you can see just the magnitude of how amazing God is, that He made all of these patterns that we see in mathematics. And this is just one of those really neat patterns that takes a little while to understand, but hopefully this demonstration will help you get through this problem a little bit better. So here's the problem that we have. It's number 5, and it says to use the math in the figure to determine the number of different paths from point A to the point indicated. Remember, no backtracking is allowed. Okay, so first we've got to talk about this backtracking. Alright, so the best way that I can explain backtracking to you is to take a look at this point J and see its relationship to point A. Now, J is over to the left and down below A. So that's the two main directions that you want to remember. So, if you will, notice the only movements that are going to be legal, according to this problem, is movements to the left or movements down. So you can go on this street map anywhere to the left or anywhere down to get to point J. And they want to know that many, how many different paths can you take. So in order to do that, let's get started. We've got to try to figure a little bit more out and understand a little bit more about this problem. So here you can see that I have put in this rectangular grid. Excuse me. And on this rectangular grid, I have different, I've marked the different street intersections here on the first part of this grid because it is fairly simple, straightforward on this part. Now, if we look at this particular point, there is only one way to get from A to that point. And then similarly, we can look at this other point with the yellow, and there's only one way to get to that point. But then I want you to think about that all of these different directions along the outer sides, there are only going to be one way to get from A to those points. It's just to go straight to those points from A. So all of our outside edges are going to have a 1. There's only one path to get to them. Now let's think about this point right here. So with this point, you have to consider you have a couple of different options. You could take the red route and you could go to the left and down, or you could go the yellow route and you could go down and then to the left. So it turns out there's two different ways to get to that point. Now if you notice, we have 1 and 1 there, and if you add them together, you actually get the two different directions. So this is going to be a pattern that we're going to see. Now consider this next point. And whenever you look at this, you're also going to have a couple of different ways to get to this point. We could take the red route and go down the red route a little bit further down that street, and you would get to it. So we know there's two ways to get to from that side. And we could take the yellow side. There's one way to get to that point. We can add those two numbers together, and there are actually 3 different directions to get to this point. And so just to kind of demonstrate to you what those different directions are, we could go down this street and straight here. That would be one way. We could go down here and then to the left. That would be another way. Or we could go down, take a jog over 1 block, and then go down. And that's your 3 different ways. Now, we have 3 ways there. And again, you see that there's a pattern. with those two corner pieces, and you add them together to get that number 3. So what I've done here is I've gone ahead and I have added all of these different corner pieces. And so if you see, I have this point 1, this point 2, you add them together to get 3. Let's take a look at this final corner point, and it's 15. And of course, you have the two diagonal pieces, 5 and 10. You add them together to get 15. So it all works out really neat. So I've decided to blow up this map just a little bit more because we're about to run into some different parts of this problem. And this is where the problem gets a little bit trickier. I want you to take a look at, there is an alleyway. Yeah, I call it an alleyway because it's smaller. So this particular little alleyway, I have this little intersection right here. Now I want you to think about how many different ways you could get to this one yellow dot. Well, it turns out that you really only have one way to get there because that's the only way you can get there. So it turns out there's only one direction, one point to get there. Now, what about this point? Well, if you notice at the intersection above it, there's 5 different ways to get to that intersection. So it turns out that there's going to be 5 different ways to get to that start of that alleyway as well. So these are actually going to be the first key points for you to understand how to get to point J. And you'll see what I'm talking about in just a second. So now I want to look at the other side of this alley. So now I've got a new yellow dot, and I want to try to find out how many different ways we can get to that yellow dot. Well, one way is to go straight down, and so that's one way, is the arrows with the red. But then you've got this alleyway that you can take advantage of now because we can get to that point from that alley. So the green arrow will take me on a little jog through that alley. So it turns out that those are the only 2 ways that you can get to that yellow dot. Now, let's continue and see if we can see some patterns. All right, let's go to the next major intersection. It turns out that there are 7 ways to get to this intersection. I could tell you all of the different ways, but maybe you'll just take my word on it. Or maybe you'll just try to find it out for yourself. But notice some patterns. We have 1 and 1 in these diagonals, and you get 2. And then you have 2 and 5 in the corners, and they add up to 7. So, if we go to that next alley intersection, can you guess how many different ways we can get to that point? Maybe we could add 7 and 5, and we actually get 12. And let's see what happens when we get to this final intersection. So, do you think you could figure out how many paths will go to that last intersection? Well, you're right. Hopefully you guessed that you can add 12 and 15 together, and you can get 27 different paths. So, now we're almost to the final destination of J. But we've got to find a few more places. We need to find all of these different locations, and that will lead us to J. So that's your task. I'll help you get started by telling you this first one is 1. And then what you're going to want to do is remember that you can take these 2 corners to get the next one and add those up to get this next intersection, add this one with 12 to get the next intersection, add this one with 27 to get J, and then you'll be all done. Now I know you're probably wondering, when am I going to use this in ministry? Well, my husband asked me the same question last night, and I told him, you know, that mission trip we're thinking about taking, and we're going to be doing some inner city evangelism. Well, I told him I have a whole class full of students who can now tell me how to get from point A to point J, and they will know exactly the number of different paths to make it to those points to do all of their evangelism. But anyway, take it for whatever it's worth. That is your explanation of question 5. I hope this helps you.